Well, hello everyone, Maple Structure here, and in today's video I'd like to show you how to analyze cantilever beam with concentrated force on the end with fixed support on the other end. Let's get started. Well, first things first, and let's get started with taking a look at the structural model. It's just a 4 meters length beam, fixed on the one end and loaded with concentrated force on the other end with value of 15 kilonewtons. The analysis of this beam is way simpler if you compare it with a simply supported beam, for instance, just because we don't need to figure out support reactions. Here we have a fixed support, which generally gives us 3 unknown support reactions, one vertical, one horizontal, and one support moment, but we actually don't need to figure them out as we will be using a method of sanctions. Initially, let's introduce the x-coordinate axis. It will help us later. Now let's get to the method of sanctions itself. By using this method, we have to cut our beam here or somewhere else, it doesn't matter. Most importantly, we have to take into consideration only the right part of the beam, just because if you use the left one, you won't solve the problem, just because we don't know the support reactions, so let's focus on the right part. Well, our system is in equilibrium, so it simply means each part of the beam is in equilibrium as well, and if we cut our beam somewhere, we must replace this missed part with internal force to keep the system in equilibrium. Alright, if our external force is vertical, it tries to bend our cantilever beam, so the internal reactions consist of 2 internal factors, shear force and the bending moment, and we have to figure them out by using statics rules. But before we are going on, I'd like to clarify one small detail I haven't mentioned in my previous video. So why those internal reactions are directed the way they are directed. And there's no secret actually, we just assume they are directed that way by using standard sign convention that you are seeing on the screen. So if we take into consideration the right part, we have to direct the moment by clockwise and shear force upwards, and by taking the left part, we're doing it vice versa. So now let's sum all the vertical forces and define the shear force. As you might see, the shear force is equal to the external force all along the beam, so the diagram looks as a rectangular. So now let's assume the left end of the beam is a point A and sum all the moments about this point. The equation is linear, so it simply means we have to take only 2 values of x to plot the bending moment diagram. Here's why we introduced the x before, by the way. The start point, where x equals 0, is the right end of the beam, so I suggest take x equals 0 point and put it into equation and x equals to the full length of the beam and plot the diagram. So we just have to connect these 2 points with a straight line. So no extra words, you can see those diagrams on the screen with all values of shear forces and bending moments we determined before. And on that positive note, I'll wrap things up. If you have any questions left, I'll be happy to answer them in the comments below. That was Maple Structure. Peace.